Hi and greetings to the respective lecturers of Integrated Design Project 1, Semester 2, Session 2020-2021. I'm Nurul Syazwani Samri. I'm from Group K16 and I'm going to present the minor department of my group, which is Erosion, Soil and Sediment Control Planning, ESCP, Water Reticulation, and Cost and Estimating. So this is the members in charge in their own department. So without further ado, let's see to the first department. Erosion and sediment control is one of the most concerning issues for many large-scale construction projects. So the job scope for the ESCP department is divided into 4 elements, which is number 1, temporary drainage, number 2, sediment basin, number 3, soil loss, and number 4, sediment yield. Temporary earth drains shall be constructed to channel surface runoff before the starting of land clearing in the project. Thus, in this project, temporary earth drains will be provided within the boundary of the project site. As the figure shown, there is altogether 4 zones representing 4 divided catchment area in the project, labeled as Zone 1, Zone 2, Zone 3, and Zone 4. For each catchment area, major drainage, which is the most critical, will be designed, and the rest drainage will follow the same design. The next one is peak flow calculation. By estimating the peak discharge, rational method is used in the project as it is simple and can provide a satisfactory estimates of peak discharge on catchments up to 80 hectares. By looking to the expression, which is QP equal to CIA over 360, we can obtain the value of peak discharge. So this is the drawing of design drainage from each catchment area from Zone 1, Zone 2, Zone 3, and Zone 4. So the next element that need to be considered in the SCP department is soil loss. So the universal soil loss equation is a semi-empirical equation used to assess soil losses under different cropping system and land management practices. Equation is a product of 6 factors representing rainfall and runoff erosiveness, soil erodibility, slopes length, slope steepness, cover management practices, and support conservation practices. Next up is sediment yield. Sediment yield estimation is used to predict the amount of sediment for sizing and maintenance of sediment control. The estimated amount of sediment storage volume is used in the sediment basins or trap design in the project. So the modified universal soil loss equation is the most frequently used equation for the sediment yield estimation. The empirical relationship for individual storm event is stated in this equation, where it required a few factors in consideration, which is sediment yield per storm event, runoff volume, peak discharge, and USLE factors. It is temporary measure with a design life for 12 to 18 months and will be maintained until the site area is permanently protected against the erosion or permanent detention basin or water quality control structure is constructed. So wherever possible, sediment basins should be constructed before clearing and grading works begins. Thus, in our project, there will be at least 1 sediment basin to be constructed within each catchment area. So this is the drawing of design sediment basin to all catchment area from Zone 1 to Zone 4. So let's go to the second minor department, which is water reticulation. So the overview of the water reticulation is number 1, calculate water demand and determine water supply. Number 2, design pipeline in the loop type of design. Number 3, execute water analysis using EPANET. Number 4, check pressure, velocity, and head loss. Number 5, design into analysis, which is fire flow and peak flow. And the last one is calculate tapping point system at water. So the water demand is computed according to Suruhanjaya Perkhidmatan Air Negara (SPAN). The table show the water demand rate for the premises or buildings include in our development plan. So it shows the average daily water demand per liters that can be used to calculate the water demand. So the table show the average domestic water demand for planning of external water reticulation system. By taking in consideration the building located in our development plan, we can calculate the peak flow by multiplying the average daily water demand to the peak factor, which is 2.5. So we can get the total of demand on the development plan. Next up is APANET system software. It is a computer program that simulates hydraulic and water quality behavior in pressurized pipe networks over a long period of several components that can be integrated by using it, such as flow of water, the pressure of each node, the height of water in tank, the concentration of chemical species, water age, and also source tracking. Next up is fire flow. It is also the crucial elements that need to be considered in designing water tank. Fire flow, or Q fire, is equal to average flow plus fire hydrant flow. So hydrant flow must be added at the highest elevation that far from the tank that required in our topography plan. So as you can see from the table, the residual pressure head can be calculated by pressure head minus by proposed level at the start node, minus by the proposed level at the end of the node, and plus by the head loss. So we can obtain the residual pressure head. Next up is head loss. So it is sufficient to assume only friction losses, but designers may, however, take minor losses into account when considering the equivalent pipeline in their calculation. So in these cases, Hazen-Williams formula is used to calculate the head loss, where some elements is required, such as effective pipe length, flow rate in pipe, diameter of pipe, and also the Hazen-Williams pipe roughness coefficient. Next up is the design of water tank. So the figures show the drawing of our water tank proposed in the development plan. We assume that the diameter of the water tank is 25 meter, and we came up with a velocity which is less than 2.6 meter per second, which is good to go. And at the last, we conclude the top water level is 18 meter from ground level, bottom water level is 11.5 meter from ground level, and the design water level is 15 meter from ground level. The last one is tapping point system. So tapping point system is calculated by using the friction head loss by Hazen-Williams formula. So in the end of the calculation, we obtain the value which is 7.858 meter, which is more than the requirement, which is 7.6 meter, and it is good to go. Hence, the suction tank is not required in this tapping point. Cost and estimating, which is the last minor department that will be discussed. Basically, in this project, the overview is including the Gantt chart, earthwork quantity, equipment and operating costs, process, cost before reduction, cost after reduction, value of engineering, and bill quantity before and after reduction. So the Gantt chart is separated to 3 parts, which is part A, part B, part C, synchronized with the area that have been divided from our development plan. So the Gantt chart is be done to track the duration of operation to be settled, so that we can minimize the cost and track the cost for overall operations. Next is earthwork quantity. So from the earthwork department, we obtain the value of total volume cut and fill for each pipe. So it is to be used to the cost and estimation calculation before reduction and after reduction. So the figure shown the site plan layout, which is divided into 3 parts, part A, part B, part C, to ease the calculation. In cost and estimating department, equipment and process is important to be considered because it can influence the overall cost taken into the project before the reduction and after the reduction. So we must know what is the respective machineries involved in respective operation. So as stated in the table, the dump truck, bulldozer and buncher is involved in site clearing operation. The excavator is involved in excavation of topsoil. The compactor is involved in compaction process. And we also must know the equipment cost per day and also the operator cost per day. After considering the operation involved, the machinery's cost and also the operator cost involved in the respective operations, we came up with a calculation that must be done to all area, which is part A, part B, and part C. So we conclude the cost before and after reduction. So the total cost after reduction is less than the total cost before reduction, which means we are on the right track and we obtain the objective of doing the cost and estimating. And we also calculate the percentage of reduction between both before and after reduction costs. And it is very efficient if we obtain the percentage of reduction more than 20%. So in our case, we obtain 31.2% and it is very effective.